Hello everyone, I am Hema Sati Sharma and student we are discussing the chapter electric current and its effect. We have already discussed heating effect of electric current and circuit diagrams. So today we are going to discuss magnetic effect of electric current. Whenever electric current passes through a wire, so the current carrying wire start behaving like a magnet. That means it exerts some kind of magnetic field around it. And this phenomena is known as magnetic effect of current. It was discovered by the scientist Hans Christian, and he found that when an electric current is passed in a wire, then a compass needle placed near it got deflected from its usual north to south position. So this we'll be seeing with the help of a picture. A straight wire carrying an electric current produces a magnetic effect, and this magnetic effect can be increased if rather than using a straight wire we use a long coil. So straight wire is or will also produce magnetic effect, but if you want to increase the magnetic effect, rather than taking a straight wire, you take the wire in the form of a long coil. And even if you want to increase the magnetic effect, what you can do, you can put a iron bar or iron rod inside this coil. So what will happen? The magnetic effect can be increased. So here we were talking about magnetic compass needle. So here it is. So this is the circuit, and you see that battery is connected and the current is flowing through this wire. So this is the symbol of switch. This is battery, and this plain line shows wire. So what is happening here? Current is flowing through the wire, and now this is a device, or this is compass needle, which is in usual position is north south. It aligns like in north and south. But if when this current start flowing, so what will happen? Because the current is flowing, it is producing a magnetic field around it, and under the influence this magnetic field, this magnetic compass needle will deflect, or it will change its position. So this shows that it has a magnetic effect. Whenever current flows through a wire, it creates a magnetic field. Now we'll be studying about solenoid. So this is the coil structure of a metal or conductor, which can, if the current passes through it, it can work as a magnet. So a cylindrical shaped coil that exhibits magnetic properties similar to that of bar magnet, which is a permanent magnet, when current is passed through it, is called solenoid, and the strength of the magnetic field shown by a solenoid depends upon the amount of current flowing through it and the number of turns of the coil. So magnetic how strong is the magnetic field will be dependent upon the number of coils. More the number of coils, more the number of turns, more will be the magnetic field, or the amount of current. So more amount of current will produce more strong magnetic field. Now we'll be studying about electromagnets. So electromagnets are the magnets which are made by using electric current, and electromagnets work on the magnetic effect of current. So electromagnet is nothing but it is the same coil which consists of an insulated wire, and it is wrapped around a piece of iron. So whenever the electric current passes through the wire or the coil, it starts behaving as a magnet. So this is the main iron rod. This is the wire which is wrapped around it. Switch is on, and this is cell, this is wire. So this way it starts behaving like a electromagnet. So here you can see this is the battery, iron rod, this is the coil structure, and it is creating this. These curved lines are showing the magnetic field which is created by electromagnet. So what is the thing in electromagnet? As long as the current passes, it behaves as a magnet, and when the switch is off, that means current is no more passing, it will not behave as a magnet. So this magnet consists of a long coil insulated copper wire around an iron rod. So it will be, when it will be connected to a cell and current will pass through, it will produce a magnetic effect, and the magnetic effect magnetizes the iron rod. This way iron rod becomes an electromagnet. So the magnetism of an electromagnet remain as long as the current is flowing in its coil. I have just mentioned that as long as the current is flowing, that for that particular duration of time, the electromagnet will work as a magnet. As soon as you will switch off, the current is not flowing, it will not behave like a magnet. So we already have discussed that what are the two factors through which electromagnet can be made more stronger. One is increasing the amount of current used, and the second is increasing the number of turns which are forming in the coil. In our next class, we will be discussing about application of electromagnets. Thank you.